This is the review for Unit 2, the quiz that we're taking that's on lessons 1 through 6. As I promised you, this video would be up by 4 o'clock, and it's currently 3:30 when I'm recording it, so it should be up by 4 o'clock. So this was the classwork that we did. I believe this was page 115. Number 1, the value of x equals 4 is a solution to all of the following equations except which? So x equals 4 is a solution to all of them except which one? So if something is a solution to an equation, I can plug it in and I'm going to get a true statement. I should not have to go through and solve all 4 of these. All I'm going to do is plug in x equals 4. 2 times 4 plus 7. 2 times 4 plus 7, 8 plus 7, does that equal 15? 8 plus 7 is 15. So this gives me 15 equals 15. That is a true statement. So that equation has a solution of x equals 4. 3 times 4 plus 1, does that equal 4 plus 11? I'm plugging in x equals 4. 3 times 5 is 15 equals 15. So 15 equals 15, this x equals 4 is a solution. 4 plus 5 equals 3 times 4 minus 3. 9 equals 12 minus 3 is 9. That's a solution. X equals 4 is a solution to that equation. Let's see what goes wrong here in 4. 4 plus 12 equals 5 times 4 minus 2. 16 equals what? 20 minus 2. 16 does not equal 18. So equation number 4 does not have x equals 4 as a solution. Which of the following is a solution to x over 5 plus 3 equals 10? Two ways to do this question. You could solve this equation, and you should know how to, or you could take your choices and plug them in. I'm going to go through and solve it because it's 2 steps. The last thing that I did was added 3, so I'm going to subtract 3. You can't multiply by 5 until only the fraction is left on that side of the equation. You can do it unless you do it carefully, but chances are you're going to make a mistake, so be careful. X over 5 equals 7 times 5 times 5. We get x equals 35. 35 is the solution. How could I check? I plug it back in. Number 3, the sum of a number n and a number 5 larger than it is 41. Well, I see that is becomes my equal sign, so I know something's equal to 41. You can't just read these once and expect to get it instantly. You have to go back and go word by word, phrase by phrase through this sentence. The sum of what? I'm adding 2 things together. Of a number, so I'm adding a number to what? A number 5 larger than it. So if my favorite number is 22, what number is 5 larger than it? 27, so I'm adding 5 here. So if my favorite number is n, what's 5 larger than it? N plus 5 is 41. Which equation represents that? Choice 2 does. N plus 5 equals 41. Number 4, which of the following is not an equation? Equations have equal signs, expressions don't. If you don't have an equal sign, you're an expression. There's an equal sign. There's an equal sign. There's an equal sign. Number 2 is the expression because it doesn't have an equal sign. You can't solve an expression. You can solve an equation. 5, which of the following values of x solves this equation? So you have 3 choices here. It's a choose your own adventure book. You could plug in the answers, plug it in, use that strategy for multiple choice. Or you could actually go through and solve it, and you should know how to solve this one. Your first choice is use the distributive property because you love the distributive property oh so much. 3x minus 18 equals 18. Add 18. 3x equals 36. X equals 12. Great. X equals 12 is the answer. Or, if you like doing less work because you're a mathematician who's lazy, I'm not going to distribute. I'm going to divide by 3. I can't add the 6 because that's not really a 6. I'm multiplying that by 3, so we need to undo the operations in the reverse order. X minus 6 equals 18 divided by 3 is 6, plus 6, and I got x equals 12. I made myself do less work by not distributing. Mathematicians are lazy. Choice 1's the answer. How do I check? Plug it in. Our friend Jenna, this is question 10. This is question 10. We skipped everything else in between there. Jenna manipulated the equation 4x plus 7 equals 10 by adding negative 7 to both sides. Great. Which of the following properties justifies this manipulation? So Jenna subtracted 7, or she added negative 7 to both sides. What property justifies this? Well, we have our properties of equality that say I can add or subtract the same thing from both sides, and that's the addition property of equality. By adding negative 7 to both sides, Jenna's not changing the solution. Jenna can add any number she wants to both sides of this equation. If she wanted to add 20, she could. If she wanted to add 50, she could. But negative 7 was the smart number to add because that helped isolate the variable x. In case you're wondering, x equals 3/4 is the solution to this equation. Notice that I left it as 3/4. 3/4 is a number. You don't need to write it as a decimal. Number 15, a rectangular garden. Stop right there. They're talking about a rectangle, and I don't have a rectangle on my paper yet. A rectangular garden has a length that is 6 feet more than twice its width. This sounds important. The length is 6 feet more than twice its width. I know nothing about the width, so I'm going to call that x. Notice that it says clearly define your variable. Let x equal the width. Let x be the width. If that's x, opposite sides in a rectangle are congruent, so that side over there is x. The length is 6 feet more than twice the width. More than and less than, whenever you see a more than and a less than, we need to start with the second half. You start with the second half with more thans and less thans. So twice the width is 2x, and I want it to be 6 more than that, so plus 6. 2x plus 6, opposite sides are the same. It takes 120 feet of fencing to completely enclose the garden's area. So you were like, ooh, I want to write a formula for the area. The 120 feet is not representing the area of the garden. The 120 feet is representing the fence around the garden. Let's pick a better color, red. This red dotted line is what I'm representing by the fence. The fence is the total distance around the garden. That's the perimeter. The perimeter is what's represented by 120. So I need to set up an equation for perimeter because I know the perimeter is 120. Well, the perimeter is, I need to add up all those sides. So x plus 2x plus 6 plus x plus 2x plus 6 equals 120. Any equation that uses the perimeter of a rectangle formula works. I think that's the most straightforward one, or you could say 2x plus 2 times the quantity 2x plus 6 is 120. Doesn't matter. They didn't ask me to solve yet. Half of you probably already solved it, but wait to the last part. Explain how your equation models the given information. Explain, write a sentence. For the sake of space, I'm going to talk through what I would write. I would write the 120 feet of fencing represents the perimeter, so I added all of the sides together and set it equal to 120. That's how I explained that my equation modeled this information. The 120 was the perimeter. I found the sum of all the sides because that's what perimeter is. And finally, we get to solve the equation algebraically. Find the length. So let's solve for x. Combine my like terms, x, 2x, x, and 2x. So that's 1, 2, 3, 4, 5, 6. I have 6x plus 6 plus 6 plus 12 equals 120. Great, this is a two-step equation. 6x equals 108 divided by 6. Don't guess, go to your calculator. 108 divided by 6 is better known as 18. So that's not where I want to go. X equals 18. X equals 18 is x, but am I actually answering the question? Kirk wants us to find the length of the garden. That's the width. X is the width. That's why I have to find my variable. So the length is 2 times 18 plus 6. Well, 2 times 18, that's 36 plus 6 gives me 42. So the length is 42. 42 is the final answer. 42 feet to be exact using our units. But that's the process that we want to go through for these perimeter questions. 19. 2 consecutive even integers. I'm stopping right there. 2 consecutive even integers. I'm going to let x equal the first consecutive integer, even integer, because I don't know what that is. Well, if x is the first one, how do I get to the next even number? I need to add 2 to it. So x plus 2 is the second consecutive even integer. They have the following property. When the smaller integer, that's x, is added to 3 times the larger, the result is, there's my equal sign. I just split this phrase into 2 different parts that I need to translate. That's one side of the equation. That's the other side of the equation. So let's deal with the purple side. When the smaller integer, x, is added to 3 times the larger, I'm adding it to 3 times the larger. Just don't write 3x plus 2. X plus 2 represents larger, so I need to treat that as one object. So 3 times x plus 2 is what? 2 less than, warning, 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 5 times the smaller. Less than means I need to start with the second half. 5 times the smaller, and I want to take away 2 from that. So I have no idea what Raphael did here, but that's the equation I set up from translating this. Ignore his work, do it on your own, and then compare your answers. So Raphael tries to model this scenario with the equation below. Unfortunately, Raphael has made an error on the left side of the equation. Don't make the error that Raphael just made. Explain what error he made. Well, he made the mistake I told you not to make. He didn't do 3 times n plus 2. He just did 3n plus 2. So there's Raphael's mistake. He just found 3 times n, not 3 times the smaller integer. So now we get to solve it. We get to use everybody's favorite property, the distributive property, multiply the 3n, 3x plus 6 equals 5x minus 2. Combine my like terms on the side. 1x and 3x gives me 4x. 4x plus 6 equals 5x minus 2. I need to collect my x's on one side and my numbers on the other. So I'll subtract 4x. And get 6 equals x minus 2. Get my numbers on the other side, plus 2, and I get x equals 8. That's good because 8 is an integer. 8 is also an even integer, which is it's supposed to be. So what's the next one? 8 and 10 are the 2 integers here that we were looking for. Number 24. 2 correct first steps are shown for the same equation below. What property justifies each step? Well, let's look at this first one. I'm always starting with 5 times x minus 3 equals 20. Remember, choose your own adventure book here. I ended up with 5x minus 15 equals 20. What did I do? Oh, here I had to use the distributive property. There I had to use the distributive property because 5 times x minus 3 is equivalent to 5x minus 15. The second one, 5 times x minus 3 equals 20, x minus 3 equals 4. What changed from this first equation to the second equation? I divided by 5. What property says I can divide by 5 and not change the solution? That's the multiplication property of equality. That's the multiplication property of equality. This next set of questions comes from page 73 in your book. This is questions 2b, C, D, and E. You should know how to solve all of the equations on this page, but if you can solve these 3, chances are you can solve the other ones. So, looking at letter B here, I have 5 times x minus 3 over 8 plus 2 equals 7. Some of you might be tempted to multiply by 8, and you can, but you would have to multiply every term by 8, and you're going to make a mistake. So, the first thing that we should do is get rid of that 2 and subtract that 2 over. And get this fraction equals 5. Well, how do I deal with a fraction? I'm really dividing by 8, so I'm going to multiply by 8. And get 5 times x minus 3 equals 40. 2 choices now. You can distribute or divide. I'm going to divide. Divide by 5. And I get x minus 3 equals 8. I don't care about x minus 3. I want x. So I'm going to add 3 to both sides and get x equals 11. X equals 11 is my solution. I can take x equals 11 and plug it in. Take x equals 11, plug it in for x, and I would get 7 equals 7. Letter C, minus 3 halves x plus 2 equals negative 4. What do we do when we see a fraction? We quit. No, we don't. We go back into letter C and actually deal with the fraction. Well, this is a two-step equation, kind of. 2x, if this was a number x plus 2 equals negative 4, I'm going to subtract the 2 over. Negative 3 halves x equals negative 6. How do I deal with the fraction? Do not divide by negative 3 halves because we're not really comfortable with fractions, let alone putting a fraction inside another fraction. So take it one step at a time. How do I undo dividing by 2? Multiplying by 2. So I'm going to multiply both sides by 2 and be left with negative 3x equals negative 12. This now I can solve because I'm going to divide by negative 3 and get x equals 4. X equals 4 is my solution to this equation. If I plug in x equals 4, I'm going to get a true statement. Letter D. There's x's on both sides, so I have to distribute here. I get 5x plus 5 minus 2x equals 6 plus 2x. Combine my like terms on the left-hand side. I have a 5x and a minus 2x. I have a plus 5x minus 2x. 5 minus 2 gives me 3x plus 5 equals 6 plus 2x. I have x's on both sides, so I have to collect them on one side. How? I have to collect them on one side somehow. And you have a choice. I'm going to move the 2x over. You could have moved the 3x over, but that's your choice. And I get x plus 5 equals 6. Well, what plus 5 gives me 6? 1 does, and if I subtract 5, I see x equals 1 is the solution. I could take x equals 1 and plug it back in and get a true statement. Or use the storage feature on my calculator. I could do 1 store x, type in this side, type in that side, and hopefully get the same result on both sides. And last but not least, letter E. Letter E. Letter E looks like a monster, but it's really not. 3 times x minus 4, I have to distribute. 3x minus 12. Be careful here. What am I actually distributing? A negative 2. People ask me what happened to the parentheses. If I'm distributing the negative 2, we don't need them anymore. Minus 6x minus 8 equals, distribute, 12 minus 4x plus 5x plus 4. Now I need to combine like terms on both sides. 3x minus 6x. I have a plus 3x minus 6x is minus 3x. Minus 12 minus 8, well, minus 12 minus 8 would be negative 20, equals what? I have minus 4x plus 5x. Well, minus 4 plus 5 is 1x, positive 1x. 12 plus 4 is 16. And now I get to solve for x. I'm going to add 3x to both sides because I have x's on both sides and get negative 20 equals 4x plus 16. Subtract the 16. Negative 36 equals 4x. And finally divide by 4. And get x equals negative 9. X equals negative 9 is the solution to this equation. How could I check it? I can plug it in. Plugging it in will tell me whether or not this is actually a solution. And it should be because we just used the distributive property, the commutative and associative properties, and the properties of equality, and I didn't change the solution because the first 3 commutative, associative, and distributive properties give me equivalent expressions, so I'm not changing what's really on both sides of the equation. And then our 2 properties of equality say I can add or subtract the same thing from both sides without changing the solution, or I can multiply and divide the same thing from both sides without changing the solution.